Hello, Algebra 1 students. This is Mrs. Raposa. In this video, you're going to learn how to factor completely. In the video, I'll be referring to this reference sheet, and it is a flow chart. And like any flow chart, start at the top. So the first thing we do in any one of these problems is we look for a greatest common factor. It'll make the problem a lot easier in a lot of cases. Once you've removed the greatest common factor outside the parentheses, what's left inside the parentheses may have 2 terms, 3 terms, or 4 terms. And if it has 2 terms, look to see if it's the difference of 2 squares. If it has 3 terms, use the trial and error method to try to factor it. And if it has 4 terms, see if it can be factored using the method of factoring by grouping. Okay, let's do some examples. Okay, Algebra 1 students, let's factor completely this trinomial. Factoring completely means keep going until it's completely done. So again, looking at that flow chart, the first thing I want to look for is the greatest common factor, if there is one. So is there a greatest common factor in this trinomial? And I can see that yes, there is. They're all divisible by 4. So my greatest common factor is 4. So what I'm going to do first is put my greatest common factor outside the parentheses and divide each term by 4 and put those 3 terms in the parentheses. 4x squared, when you divide it by 4, is just x squared. 4x divided by 4 is positive x. And negative 24, when I divide it by 4, is going to give me negative 6. So I have 4 times this trinomial. And you may think you're done, but we always want to see, can this trinomial be factored even more? And it actually can. So I'm going to set up my 2 sets of parentheses. Did you notice I set up my 2 sets of parentheses to make this, but I also pulled down the factor of 4 too, because now I have 2 factors. I'm going to make it into a product. This is going to be a product of 3 factors now, those 3 factors. So to do that, I look for the factors of my x squared term, and I look for the factors of the constant term, negative 6. So the only way to get x squared is x and x. So I know that's going to be the first thing in each set of parentheses. Now, to get negative 6, I'm going to have, when I multiply to get factors of negative 6, I have to have a positive and a negative number. So I know one's going to be positive and one's going to be negative, my constants in the term. I can just take a look at my factors of negative 6. I can do negative 1 times 6, right? I could do positive 1 times negative 6. Or I could do negative 2 times 3. Or I could do positive 2 times negative 3. These are all the the factor pairs that would multiply to negative 6. What I need to do is, since this is a leading coefficient of 1, I want to find the 2 numbers here that add up to a coefficient of positive 1, positive 1x. It's not this, that adds up to 5, this adds up to negative 5, this adds up to positive 1. So I need it to be negative 2 in one set of parentheses and positive 3 in the other set of parentheses. And none of these 3 factors can be factored more. So I'm done here. I have factored it completely. Just showing you why this is important to get the greatest common factor. Suppose I had forgotten to get the greatest common factor out and tried setting up parentheses to get 4x squared plus 4x plus 24. There's so many different ways I can get 4x squared. I can get 4x times x, or it could have been 2x times 2x. And each one of those I'd have to try with how many different ways are there to get negative 24? There'd be so many different factors. Negative 1 and 24, positive 1, negative 24, negative 2 and 12, or positive 2 and negative 12. And then there would have been negative 3 and 8, positive 3 and negative. There's so many different ways. I would have had to try all those to find the one that worked. And I mean, there is going to be one that works, but this is a lot easier to pull out the greatest common factor first. So that one's done. Okay, let's do the second example. Like I said, looking at that flow chart, I always want to see if there's a greatest common factor first, make my problem easier. However, for these 4 terms, there is no greatest common factor, so nope, there isn't one. So I can't pull out a greatest common factor. But the next thing I want to do is look at my flow chart. Since I can't pull out the greatest common factor, is there 2 terms, 3 terms, or 4 terms? And I can see here that there's 4 terms. So let's try factor by grouping. So I'm going to group the first two together, and I think there's a little bit of a glare on the board over here, so I'm going to have to move over a little bit. And then I'm going to group these two together. Well, in these two terms, the greatest common factor is x squared. There's no number here, there's no coefficient. And whenever there's the same variable in two terms, your greatest common factor for these two terms, not for the whole thing, greatest common factor just because we're factoring by grouping. The greatest common factor in these two terms is going to be that variable that shows up in both terms raised to the smallest exponent. To have an exponent of 3 and 2, the smallest exponent is 2, so it's x squared. And let's find the two terms that go in the parentheses that I multiply by x squared to get this. To do that, I do x cubed divided by x squared. We've done that a few times. X cubed is x times x times x over x times x. These cancel. You're just left with x over 1 or x. So x cubed divided by x squared is x. Now we divide positive x squared by x squared. Well, I'm dividing something by itself. Anything divided by itself is just 1. So that ends up being x squared plus 1. X squared times x plus 1. Looks like I'm going to have to move it over so you can see it. X squared times x plus 1. Okay, maybe you can see it. And then the greatest common factor in these two terms is negative 9. So I'm going to pull up, remember, I need a sign here. I don't want to just put 9. I have to know whether it's positive 9 or negative 9. In this case, it's negative 9. And hopefully, this binomial is the same as this one. So I'm just going to put it here and then see if it works. X plus 1 here. Does negative 9 times x give me negative 9x? Yes. Does negative 9 times positive 1 give me negative 9? Yes. So I have x squared times x plus 1 minus 9 times x plus 1. Well, since they have a common binomial factor, I'm going to put that common binomial factor first. And in the next set of parentheses, it's going to be this term, x squared, and this term. They go together. So I have that this is equal to x plus 1 times x squared minus 9. And it doesn't matter whether you put the x squared minus 9 first and the x plus 1. It doesn't matter because multiplication is commutative. You can do it in any order. And you may say, okay, good, I'm done. However, I want to see if I'm done completely. So I have a two-term expression, a two-term expression. Let's look at our flow chart, right? The two-term expressions, is one of them a difference of two squares? And guess what? It is. This one is a perfect square. This is a perfect square, and it's the difference of them. So this can be broken down some more. X squared minus 9, I can set up my two sets of parentheses, two binomials that multiply to give me x squared minus 9. This is a perfect square. The square root of x squared is just x. The square root of 9 is 3, so that's going to be my second term in each set of parentheses. And because it's the difference of two squares, remember if you look at the paper here, it's going to be a plus b, a minus b. In this case, a is x, b is 3, so x plus 3 and x minus 3. I'm not done though, because if I multiply these two together, I don't get all of this. I only get this, so I need to pull down the other factor, x plus 1. So this four-term expression ends up being the product of three binomials when I'm all done. Okay, let's do the last two examples, example 3 and 4. Remember, the first thing we want to look for, always look for the greatest common factor first. And in this trinomial, three-term expression, there really is no greatest common factor. There's no number that everything's divisible by. There's no variable in each term either. So there is no greatest common factor. So nope, don't have to do that. So now I just have to look for the strategies for factoring completely for three-term expressions. And for the three-term expressions, use the trial and error method of factoring. So let's do that. I'm going to just do my trial and error method. So what I need to do is find factors of n squared and factors of negative 1. Well, the only way to get n squared is n times n. So I know that's going to have to be the first thing in each set of parentheses. And negative 1 is a prime number. Well, it's a negative prime number. The only way I can get negative 1 is negative 1 times 1. That's my only possibility. That is a negative. The constant term is negative, so I know I'm going to have different signs in each set of parentheses, plus and a minus. But I have an issue here. We have a problem. If I put positive 1 and -1 and test it out, if I multiply those, just let me get rid of this. Let's check it. If I check this, first will be n squared, outer will be n times -1, inner will be +1 times n, and last is +1 times -1. If you use the box method, you could do the box method as well. The like terms here cancel each other out, and I'm left with n squared -1, so that doesn't work. This is actually not even factorable, and sometimes there's no greatest common factor, and then there's no factors either, so that doesn't work. Nope. So this is not factorable. Just know that sometimes that's the case. I think on the last homework there was one problem that wasn't factorable. It was because I made a mistake on one of the problems, but that's okay. That happens sometimes. So if it's not factorable, you just say I can't factor it. I have to just leave it the way it is. It's already factored completely. Let's take a look at the last example. Again, I don't want to go to the flowchart and say, oh, it's a two-term expression, but it's not the difference of two squares, so I'm done. Always look for that greatest common factor first. Always. I'm going to get rid of this other stuff up here because it's getting a little confusing to look at everything all up here. So let me get rid of it. We did that one already. So now let's take a look at what the greatest common factor is. Is there a greatest common factor? And I can see that there is, I erased this exponent of 4. Oops. The greatest common factor here, number-wise, is a 2. But each term has h in it also. And remember, the one that I want to pull outside the parentheses is going to have the lowest exponent here. I have an exponent of 4 and an exponent of 2. So my greatest common factor is going to have h squared in it. So I'm going to pull the 2h squared common factor outside the parentheses and figure out what's inside the parentheses. Well, now to get what goes here, I'm going to have two terms in here. I do 50h to the 4th. I like to do h to the 4th like this. That is h to the 4th. And I'm going to divide it by 2h squared. Well, 2h squared is just 2 times h, right? Well, this cancels. H over h is 1. This also cancels, h over h. And 50 divided by 2, well, that reduces to 25 over 1. So I'm left with 25 times h, all over 1. Well, 25 times h, that's just 25h squared. And now I want to divide -2h squared by 2h. So divide the next term by the common factor, 2h. Well, 2h squared here. Did you notice that I have the same thing in the numerator as I do in the denominator, only this one's negative? Anything divided by itself is 1, so in this case it's going to be -1. And you may say, okay, I'm done, and say, okay, I did it. Factored out, the only thing is the greatest common factor. But remember, I always want to see if I factored it completely. Am I really done? Let's take a look. I see a two-term expression. So is it the difference of two squares? This is a perfect square, and so is this. So it is the difference of two squares. So I can write this two-term expression as a binomial times another binomial. Don't forget that when I multiply these, I'm only going to get this, so I'm going to pull down this factor of 2h squared also. So two terms comes to the product of two polynomials, and now I'm going to make it the product of 3 polynomials. So I need to figure out what times itself gives me 25h squared. Basically, I'm taking the square root of 25h squared. Well, the square root of 25 is 5. And the square root of h squared is h. So 5h times itself would give me 25h squared. Since it's the difference of two squares, I know I'm going to have the first term in each set of parentheses is the same number. The last constant in each term is the same number also. It's just that one's going to be positive and one's going to be negative. So to get -1, I can have +1 and -1. I'm basically taking the square root of 1. So 5h plus 1 times 5h minus 1, that gives me 25h squared minus 1. But when I multiply that by 2h squared, I get back to this two-term expression. So now I have factored it completely, and we're done. Don't forget you can ask your teachers questions. Go to the Google Meets, and if you have questions and work through the homework. Hope that helped.